Back to the channel. So today, in today's video, we're going to be doing something similar to the last video, and it is going to be more practice with continue and discontinue, because this is a very important concept. Sorry, rewrite that bar. This is a very important concept in limits. So let's just get started with this problem, right? So it's 5 right there, yeah. So this is given, we are here given f of x, and this is a piecewise function, right? So when x is not equal to 5, our graph is x squared minus 25 where x minus 5, where x is not equal to 5, and 10 where x is equal to 5. And it's continuous at x equals 5. So it's asking if it's continuous at x equals 5, sorry. So if you don't really understand what continuous means, right, I'm just going to use that term here anytime in the video. Please make sure you go back and watch our intro to continuity video, and then you'll understand, like the criteria. So like some of the criteria for being continuous that we discussed in the last video was that f of x has to exist, right? The value at f of x has to exist. The limit as x approaches whatever value has to exist at that point, and those two previously mentioned values have to be the same. They have to equate. So if those things are true, then the function is going to be continuous. So let's solve for it and see, right? Well, here already we know that when x is equal to 5, f of x equals 10. So f of 5 equals 10. So that's already one criteria fulfilled, right? At f of 5, the value does exist. All right. Now we're moving on to our next value, right? On the next criteria. So does the limit exist, right? So the limit as x approaches 5, for this function, right? Well, we're gonna have to factor, right? Because otherwise the denominator will be 0, and our function will be undefined. So if we so now we're gonna have to factor here. So the limit as x approaches 5. We can just factor this right now, right? X minus 5, x plus 5, right? Because that's x squared minus 25 is x minus 5, x plus 5, right? Over x minus 5, right? In the denominator here. X minus 5 cancels with the x minus 5 in the numerator, right? And now all you have left is x plus 5, right? Now we can sub back in that 5, right? So you can sub back in this 5, right? 5 plus 5 is 10. And this is equal to 10. So now you can see that the value exists, the limit exists, and these values are the same, 10 and 10, right? And so that's how you know that this is continuous, and that's all there is. Thank you.